Today, on Guess What I Found Out, we're going to discover some facts about the universe. Specifically, the 95% of it that scientists cannot see, cannot touch, and cannot fully explain. Just to recap, everything you have ever looked at, stood on, eaten, loved, or found mildly annoying. That accounts for roughly 5% of everything that exists. The rest is a mystery, and we've just found a piece of it. Let's set the table. The universe is made of three things. First, ordinary matter, called baryonic matter, which is atoms, protons, neutrons, the stuff that makes up stars, planets, gas clouds, your coffee, your cat, and every galaxy ever observed. That's 5%. Second, dark matter. Not dark like a color, dark like invisible. It doesn't emit, absorb, or reflect light. We can't see it, but we know it's there because it has gravity, and gravity has consequences. That's 27%. Third, dark energy. A mysterious, repulsive force that's driving the universe to expand faster and faster. We don't really know what it is. That's 68%. So, unknown, and 5% stuff we actually recognize. Great start. Now, here's where it gets even more fun. Of that 5%, the ordinary matter we can actually see, only about 60% has been accounted for. Astronomers can point at it, stars, gas, dust, plasma. The other 40% of our 5%, missing. Since the Big Bang. For 13.8 billion years, physicists have known it should be there. The math from the cosmic microwave background, the faint glow of radiation left over from the early universe, predicts exactly how much baryonic matter should exist. And yet nearly half of it refuses to show up. This is the cosmological equivalent of baking a 20-piece batch of cookies, finding 12 on the counter, and just accepting it for 14 billion years. If your jaw dropped even a little, go ahead and hit that like button. This is exactly the kind of thing Guess What I Found Out exists to tell you about. So, where has all this matter been hiding? The leading theory, and you know it's backed by increasingly good evidence, is the cosmic web. The universe isn't a uniform soup of stuff. It's structured like an enormous three-dimensional spider web. Long strands called filaments stretching hundreds of millions of light years, connecting massive nodes called galaxy clusters with vast empty voids in between. Our own Milky Way sits in a local group of galaxies which sits in a supercluster called Laniakea. That's 100,000 galaxies across 500 million light years, strung along these filaments like beads on a wire. The missing baryons, scientists suspected, were lurking in those filaments. Not in galaxies, not in clusters, in between, as a diffuse, incredibly hot, incredibly thin plasma between 100,000 and 10 million degrees Celsius. It's called the warm-hot intergalactic medium, or WHIM, which is also, incidentally, how most cosmologists sound when trying to explain this at dinner parties. The problem is that WHIM is almost impossibly hard to detect. It's hot enough to emit X-rays, but so diffuse and faint that it barely registers. For decades, simulations kept predicting it was there. Observations kept almost but not quite confirming it. Indirect hints piled up. Gravitational lensing detecting dark matter filaments. Quasar light briefly illuminating hydrogen threads. X-ray glimpses from Chandra and XMM-Newton that were suggestive but never conclusive. The history of this search is essentially the history of astronomy going, we think it's there. We almost saw it. We're pretty sure. We really need better instruments. Drop a comment below and tell us, did you have any idea the universe was this dramatically incomplete? We want to know where you're starting from. Curious George, do not hold back. Then, in June 2025, a team led by Konstantinos Migas at Leiden University did it. Using JAXA's Suzaku X-ray telescope to map faint emissions across a wide area, and XMM-Newton to filter out contaminants like supermassive black hole radiation, they directly detected a cosmic filament. Not inferred, not suggested, directly detected. It is 23 million light-years long. That is 230 Milky Ways, end to end. It connects 4 galaxy clusters in the Shapley Supercluster, a region with over 8,000 galaxies, and it has a temperature of 10 million degrees Celsius and a mass roughly 10 times that of the Milky Way. The X-ray imaging showed a honeycomb-like texture, like the bones of the universe finally rendered visible. And it matched the simulations. almost perfectly, which means the missing baryons aren't missing anymore. They're in the web. They've always been in the web. We just didn't have the tools to see them until now. This is not just a cool discovery. It has consequences. The leading model for how the universe formed and evolved is called Lambda Cold Dark Matter, LCDM. It describes a universe where slow-moving cold dark matter, baryonic matter, and dark energy interact to produce the large-scale structure we observe. Every time we find missing baryons exactly where that model said they should be, it gets harder to poke holes in it. This discovery is a vote for the Big Bang, for nucleosynthesis, for our best current understanding of how everything came to be. If you're not already subscribed to Guess What I Found Out, this seems like an excellent moment. We spend a lot of time here finding out things that rewrite how big the universe actually is. Come along. What happens next? The Euclid Space Telescope, launched in 2023, is currently mapping the cosmic web at a scale never attempted before, using gravitational lensing to trace dark matter filaments and redshift measurements to pin down galaxy positions in 3 dimensions. Euclid could, by 2030, either lock in the LCDM model as the definitive framework for cosmology, or expose cracks in it. A mismatch between what Euclid sees and what the CMB predicts would mean something fundamental is wrong. With dark matter, with our model of gravity, with our understanding of the early universe. The stakes are, by any reasonable measure, about as high as stakes can get. The universe is made of 95% stuff we cannot see. We've just found a piece of the 5% we thought we understood, but couldn't locate. And the skeleton of everything, billions of light years of glowing X-ray hot gas woven between the galaxies, is finally starting to come into view. Not bad for a Tuesday. On the next episode of Guess What I Found Out, we'll be jumping into something completely different, because that's what we do. Hit subscribe so you don't miss it. We'll see you there, Curious George.